pleasant day to all of the viewers, especially to our panelists. We are honored to present our capstone project entitled Larynx, an accessible communication tool for the deaf and non-speaking community using a hand gesture recognition model based on keypoint detection with interactive speech buttons. This project aims to create a mobile solution that supports inclusive communication between deaf, non-speaking, and speaking individuals. Before we begin, allow me to introduce the members behind this capstone project. Each of us contributed to the development and completion of Larynx through our individual roles and teamwork. I am Kathleen Castro, together with my groupmates, Trisha Nicole De Asis and Nino Greg Gregorio. So again, our thesis title is Larynx, an accessible communication tool for the deaf and non-speaking community using a hand gesture recognition model based on keypoint detection with interactive speech buttons. Our study focuses on developing a mobile-based communication tool designed to recognize hand gestures and integrate speech features. It aims to provide deaf and non-speaking individuals with a more accessible way to interact and communicate effectively with speaking users. Before we discuss the details of our system, let us first understand the reason and motivation behind conducting this study. Communication barriers remain one of the major challenges faced by the deaf and non-speaking community, particularly in interactions with speaking individuals. Existing assistive technologies often fail to provide two-way communication or lack of accessibility. Our study introduces Larynx, a mobile-based system that uses American Sign Language gesture recognition through keypoint detection. It integrates speech and text features, enabling users to communicate in real time. Through this system, we aim to foster inclusivity, accessibility, and understanding among individuals regardless of their communication ability.
The study focuses on the communication difficulties experienced by deaf and non-speaking individuals, particularly the members of the abot kamay na may mga kapansanan ang pag-unlad ng Pasigenyo or AKAP in Manggahan, Pasig City. These individuals often find it hard to communicate with others, especially when they are not accompanied by family members, friends, or interpreters. In urgent situations, such as emergency, they struggle to express their needs clearly. In addition, most speaking individuals who are not familiar with sign language, which makes it difficult for both parties to understand each other. This situation emphasizes the need for a communication system that can bridge this gap and promote inclusivity and accessibility. To address this general problem, the study aimed to solve the following specific problems. First, how to detect hand gestures directly or accurately from users with different hand sizes and skin tones using a mobile-based recognition system to ensure inclusivity and gesture-based communication. Second, how to assist speaking individuals in responding to deaf or non-speaking users without requiring prior knowledge of sign language through a two-way communication system. Third, how to support users with communication disabilities who have difficulty typing or reading by providing alternative input and output methods for easier and more effective interaction. And lastly, how to provide a quick and clear way for deaf or non-speaking individuals to signal for help or alert others during emergencies. Overall, the study seeks to develop a system that promotes inclusive, accessible, and efficient communication between deaf, non-speaking, and speaking individuals.
Our system uses super-based authentication to keep all the user data and information safe. If a user does not have an account yet, they can create one by visiting the sign-up page and filling out the registration form. After submitting, the system will send a verification code to their email, and the user must verify their email to activate their account. For faster access, users can also log in using their Google account through Google Authentication. Once the account is verified, or if the user already has an account, they can go to the login page and enter the registered email and password to access the system. After logging in, users will be greeted on the home page. This page provides easy navigation to all features of the system, allowing users to explore and use the app more conveniently. Now let's talk about the first feature, the communicate. In here, the non-speaking user can interact with speaking individual using the text-to-speech and speech-to-text feature, making their basic conversation easier. Hello. Goodbye. The second feature helps user communicate using basic sign language. The system can recognize and convert simple sign language gestures into text and speech, allowing non-speaking users to communicate effectively with others. Next is speech buttons. This feature provides pressed speech buttons that play specific messages using text-to-speech. For example, users can press a button to say hello or thank you. The speech buttons are organized into different categories, helping users respond quickly based on the situation or conversation context.
Please. Please.
Users can also create their own speech buttons. By selecting Add Custom Speech button, they can personalize what each button says. If an audio source is used, a guardian can record or provide the voice or speech that will play when the button is pressed. Next is the SOS feature. This feature serves as an emergency alert system. When activated, it triggers an amber alert sound and flashing lights on the device. This helps signal emergency such as an accident or natural disaster and alert people nearby. Next is Learn. This feature helps non-speaking users learn basic sign language. It serves as a learning tool for those who are new to sign language communication. Next is the settings. In here, users can view and interact on their favorites and custom speech buttons. They can also customize the content or display of the application based on their preference. For example, the user can change the theme from light mode or dark mode. They can also change the language of the app between English and Tagalog. And lastly, the user can change the audio or volume of the app, and the selected volume will be set to the device immediately. To check how well the system performs, we carried out an evaluation that combined accuracy testing and user feedback, following the ISO 25010 quality standard. We used a hybrid hand gesture model, and to make sure the test was fair, we evaluated it using a separate dataset containing 23,052 images, which represent 20% of the total data. The model achieved an accuracy rate of 97.38%, while the error rate was only 2.62%. This means that the system was able to correctly identify most hand gestures, even when the users had different hand shapes, sizes, or skin tones. The second part of the study focuses on improving communication between speaking individuals and deaf or non-speaking users. This is aligned with SOP2, which aims to support equal and easy interaction between both groups. During testing, the results for functionality were 3.48, which is agree, and for reliability is 3.41, which is also agree. This score shows that the system's communication tools, such as text-to-speech and speech-to-text, work properly and met users' expectations. Users also shared positive feedback, saying the feature made it simpler to express and understand messages in daily conversation. For SOP3, the main goal is to assist users who find reading or typing difficult, ensuring that the system remains inclusive and user-friendly. Evaluation results shows that the system scored 3.58 for usability, which is strongly agree, and 3.49 for efficiency, which is agree. These scores means that most users found the interface simple, clear, and easy to explore. The system also allows flexible ways to input and output messages, which makes interaction less complicated for users with different disabilities. Finally, for SOP4, the focus is on giving users a quick and dependable way to call for help in emergency situations. These features include functions like alert sounds and flashing signals designed for urgent or life-threatening conditions. Based on the evaluation, maintainability scored 3.46, which is agree, while portability achieved 3.67, which is strongly agree. This results indicates that the system is stable, adaptable, and can run on various devices without problems. This shows that the emergency alert system is not only effective, but also ready to be used in real-world scenarios, such as accident or natural disasters, where quick response is crucial.
After completing the system evaluation, we identified several areas that can still be improved. The following recommendations are proposed to enhance Larynx functionality, accessibility, and overall performance in future development. Our first recommendation is to expand the system's recognized hand gestures to include more dynamic movements, words, and phrases. This will allow users to express themselves more naturally and communicate a wider range of thoughts and emotion through sign gestures. Next, we recommend adding an emergency alert feature with GPS tracking capability. This function would enable users to send their real-time location automatically during emergencies, allowing faster and more accurate response from nearby individuals or authorities. We also suggest making the system available on other platforms such as iOS, as well as on wearable devices like smartwatches. By doing this, Larynx can reach a wider range of users and provide more convenience for daily communication. Another enhancement we propose is the addition of a text-to-sign language conversion feature. This would allow messages or responses to be displayed visually in sign form, which will help users with reading difficulties better understand the content being communicated. Lastly, we recommend including multilingual and regional sign language support. Through this improvement, users from different linguistic and cultural backgrounds can communicate more effectively, making the system more inclusive and culturally adaptive. That concludes the presentation for our capstone project. Through this study, we aim to develop an exclusive system that helps bridge communication gaps and promote accessibility for individuals with speech and hearing impairments. Once again, thank you very much for your time and attention.